I'd like to go into a bit revision for your term test 2 that's going to happen this evening. Okay, in fact, this is one very important lecture. Yesterday, about 10 students come and see me, and they ask very similar questions. And I like to highlight the question that they ask. And I also want you to like get a better understanding more than anything else. So the revision will be on instantaneous center. And if I have time, I'll go through planetary gears, okay? So the example that I want to look at, okay, is this one. Okay. So what we are going to look for, right? And you have done this, by the way. You have done this. We know that from the instantaneous method, right? We found that Vc is equal to 0.204 meters per second. And from the instantaneous method, we also discovered that omega Bc, right, is equal to 1.983 radians per second, and is in this direction. Okay. Now, let me elaborate on this point. Okay, let me elaborate on this point. But before we go there, so how do we construct the velocity vectors, okay, for instantaneous center? So we know that from here at point B, we know that the velocity vector is going in this direction. Okay. There's no assumption over here. This is a true direction. Okay. Why there's a true direction? Because over here, this is 90 degrees and this is BD. It has to be 90 degrees because point A is what? In. Are we clear? Okay. Now on D, likewise, right? We are also aware that the velocity vector is coming down this way. Okay. I'll try to draw such a way that it's not 90 degrees from BC. And we know that over here, this is what? 90 degrees. Okay. Yes. You just show. Okay. So from here, we knew when we construct our instantaneous center, we draw a line over here. Okay. Then we draw another line over here. So over here, we knew that this is our what? Instantaneous center. Okay. Now, watch this. Watch this now. Now we know that omega ICB will be equal to omega ICC. And likewise, we know that this is equal to omega what? BC. It's also equal to omega BC. Why? Because the instantaneous center that we have just done, okay, is for ICB, BC, and CIC. So all of them will rotate in this direction, that is 1.983. So this will also rotate 1.983. This will also rotate in this direction 1.983. Okay, relative to IC. Are we clear? Okay, now there's a very unique thing about member BC. I repeat again, there is a very unique thing about member BC. What is so unique about member BC? Member BC share the same what? if you look at the IC domain, member BC is there. If you look in the real structure domain, member BC is also what? There. Yes or no? So if we look at in the IC domain, right? If I were to draw another green line, okay, this is our member BC. Yes or no? In the real geometry domain, we also have what? So I'm going to take this whole thing. Okay. Member BC is also over here. Agree? From the what? From the IC domain, we know that this rotation is equal to what? 1.983 radians per second. Yes? Now, if we go to the rho domain, BC also has to rotate by what? You see what's happening now? Okay, so in the IC domain, we found that this is 1.983. In the rho domain, BC is also rotating in that direction that's going at what? 1.983 radians per second. Prove it. No. BC in the IC domain and BC in the rho domain, they share the same geometry, they share the same orientation. Okay? So the next thing that you ask Eugene, prove it. Yes or no? So how do we know this is right or wrong? Anyone? The only way to prove this is we have to use a different method. And when we use a different method, BC must be equal to what? 0.204. If it's not, the theory is garbage. Welcome to Donald Trump for the next 4 years. Unbelievable. But anyway, good for stock market. Okay. I might buy your pizza at the end of the term. So now we are going to use, okay, we're going to use relative velocity method. Vc is equal to what? 0.204 feet per what? Per second. Okay, we use relative velocity. Okay, so we know that Vb, so we are going to consider points A and point B. We're going to consider that. Okay, so we are going to write Vb is equal to Va plus by omega AB cross RB from point A. Okay. So we know that VA is equal to 0 because it's spin. So we are going to find what is our VB equal to. Okay. So VA, we know is 0, is going in the anti-clockwise plus by 3K multiplied by V relative point from point A. So this is equal to 2 cos 45I plus by 2 sine 45J. Okay. So this will be equal to 3K cross 1.414 I plus by 1.414 J. Okay. So this 3 multiplied by 1.414 no, 3 multiplied 1.414 is 4. So K cross I is positive 4.242 J, then minus 4.242 I. Okay, I'm going to rearrange this a bit. So this is minus 4.242 I plus by 4.242 J. Okay, we've done that. So the next thing that we do, we look at VC or consider point C, and also we want to consider point B. Okay, consider point B and C. I'm going to get this diagram down. So we have shown previously that the angle over here is equal to, I think it was equal to 43.1. Okay, we have shown the angle down there to be equal to what? 43.1. Okay. So now again, we write the term BC is equal to VB plus by omega BC cross RC from point B. Okay. So BC is what we want to find out. We know what is VB minus 4.242 I plus by 4.242 J. Then this will be equal to minus. Now, this is where we incorporate omega BC to prove our hypothesis that this is 1.983 minus K. Are we clear? We're going to substitute in there and see what will happen. So this is equal to minus 1.983K, and then cross. Again, I'll move this diagram away. Really. Okay, then I'll write again minus 1.983K cross. Then we have our 43.1. So we have cos. So 3 cos 43.1 I plus by 3 cos or sine 43.1 J. Okay. So now we just need to put the numbers in. Okay. So this is minus 4.242 I plus by 4.242 J. K cross I is positive. We have a negative down here. So this will be minus 1.983 times by 3 times by cos 43.1. 4.344. K cross I is equal to J. Now K cross J is negative. We got negative, then we have to be positive. So 1.983 times by 3 times by sine 43.1 is equal to 4.065 I. Okay, so finally, we have minus 4.242 plus by 4.065 minus 0.177 I plus, I don't know whether it's plus or not. So 4.242 minus 4.344 minus by 1.0 or 0.102 J. So therefore, VC is equal to 0.177 or, okay, if we include the minus sign, okay, because it's squared, it will not be there. 0.177 squared plus by minus 0.102 squared. So this is equal to 0.177 squared plus by 0.102 squared, the whole thing square root, 0.204. Oh, not meters per second, come on. Have you seen this number before? Yes or no? Number is over here. Okay, so Over here, this is important. Okay. Now, again, any questions from here? Anyone? Yes. Can you look at the notes? Okay. It took quite a while to get there. Okay. It's not difficult. It's all purely what? Geometry. Okay. Oh, crap. Did I record? I did. Right. So now, yesterday I did this question 9 times. Okay. 10 students came to see me and I have to do this question 9 times. Okay. We are going to, again, this is regarding, is this a good example? Yes or no? Right? This is a good example, right? We are going to use instantaneous method again. Okay. It's not difficult at all. Okay. Right. So we are going to use instantaneous method. Okay. So now we are going to construct 2 circles. Okay, we're going to construct 2 circles. And deliberately, I'm going to construct the circle using a lighter pen, so you can see things better. Do I have time? Yeah, I have time. I don't need to rush. So this is 1 circle. And I'm going to have another circle. A bigger circle. Circle. Okay. So over here, the center of both circles